One task that comes up from time to time is determining whether two texts are the same or different. For example, sometimes if you're studying different editions of a particular published work, you might want to compare the two editions to see which parts have been changed and which parts are the same. Mathematica includes a number of commands that allow us to do tasks related to file differences, and we're going to look at some of these right now. For example, one thing that we can do is we can check to see whether two files are exactly the same or not with a technique that uses what's called a hash function to create a kind of fingerprint. Here are three texts. I'm just going to evaluate these three so that they're saved in their symbols. Here are three texts that are quite similar to one another, and it would be difficult to tell if or where the differences are unless you know. But if we want, what we can do is we can create what's called a hash of each text. And if the hashes are the same, the texts are the same. And if the hashes are different, the texts are different. These show us that these three texts are different. Even the small difference in the original file leads to a very large difference in the hash, and that's why they're useful. Okay, so these three texts have separate hashes, and therefore they're three distinct texts. How can we find out where they differ? Well, we can use a function called sequence alignment to try to align each character in the two texts and show us what's different. So if we compare text A with text B, we see that, I'm just going to highlight this, we see that text A has a 1 before the three zeros, and text B has a lowercase l. So those two files differ in that character position. If we compare text B to text C, we see that one of them has a lowercase l followed by three zeros, and the other has the numeral 1 followed by three capital O's. And finally, if we compare the first and the third, we see that they differ. One has three zeros and the other has three capital O's. Now, the sequence alignment is useful not only for seeing character differences like that, but it can also show us insertions and deletions. Here's a fourth text, text D. If we try to align texts A and text D, we see that text A has the word about in it, and text D, that word has been deleted. Text A doesn't have a word, where text D has the word new inserted. In one of the files, text A, this word is line, L-I-N-E, and in the other it's lime, L-I-M-E, and so on. Now this is character by character comparison. If we wanted to compare at the level of words, we would just use text words to break each text into words first, like this. So this shows us one text has about, the other has nothing. One text has nothing, the other has new. One text has line, the other has lime. We can also use a command called edit distance to tell how close one thing is to another. So for example, text A and text B differ by one edit, where an edit is an insertion, deletion, or substitution of an element. Texts A and C differ by 3, and texts A and D differ by 11. So edit distance gives us a nice measurement of how different two texts are. We can also use something called the distance matrix to compare the edit distance between every pair of texts. Let's see what that looks like. Here it is in numbers. We can visualize it a little more readily. And what this shows us, for example, text A is the first row and the first column. It doesn't differ from itself at all, of course, so the edit distance is 0, and that's true of each thing on the diagonal. The distance from text A to text B is 1 edit, from text A to text C is 3 edits, and from text A to text D is 11 edits. Visualized like this, we can see the darkest colors indicate the most difference between a pair of texts.